Allow me to share a narrative with you. In my youth, I was fascinated by locomotives. Imagine this: you are a passenger on a train moving at 60 miles per hour, and you begin walking toward the engine at a pace of 3 miles per hour. What is your actual speed? An observer on the station platform would calculate it at 63 miles per hour. This seems self-evident, doesn't it? You simply combine the velocities. This was the understanding given to us by Galileo and later by Newton. For 3 centuries, this principle served us without fail. However, a peculiar development occurred in the 19th century. A gentleman by the name of Maxwell appeared on the scene and formulated a series of equations describing electricity and magnetism. They were truly elegant equations. And what should emerge from these mathematical expressions as if a gift from the universe? The speed of light. It wasn't a changing number. It wasn't something contingent on your own velocity. It was simply a fixed value, an unwavering constant of approximately 186,000 miles per second. Now, this was perplexing because, according to the principles of Galileo and Newton, if I were on a train traveling at half the speed of light and I switched on a flashlight pointing forward, the beam from that flashlight should be moving at 1.5 times the speed of light from the perspective of a stationary observer. Correct? Yet Maxwell's equations insisted this was not possible. The speed of light is the speed of light. Full stop. It makes no difference whether you are in motion or at rest. If you measure the velocity of light, the result is always the same. So, we found ourselves with a dilemma. Either Maxwell's work was flawed or Galileo's was. One of them had to be incorrect. And wouldn't you know it, the prevailing wisdom in the 1880s was that Maxwell must be the one in error. After all, his equations were new, only 2 decades old. Galileo's principles had been validated for 300 years. Surely, all that was needed was a minor adjustment to Maxwell's work to make it align with the traditional method of adding velocities. But then came the Michelson-Morley experiment. This is, without exaggeration, one of the most crucial experiments ever conducted, and I want you to truly grasp what they were attempting to discover. At that time, physicists held the belief that light behaved as a wave, much like sound waves traveling through air or ripples on the surface of a pond. And if light is a wave, it must be undulating through some medium. They named this medium the ether, an invisible substance that they believed permeated all of space. Now, if this ether existed and the Earth was traversing through it at roughly 20 miles per second on its orbit around the Sun, then we should be able to detect an ether wind. This is analogous to holding your hand out the window of a moving vehicle. You can feel the wind, not because the air itself is moving, but because you are moving through it. Michelson and Morley constructed a brilliantly clever apparatus, an interferometer, capable of measuring the speed of light in various directions. If an ether wind was present, light traveling against the current should be slower than light traveling perpendicular to it, right? They performed the experiment. They took measurements with extreme precision. And do you know what they discovered? Absolutely nothing. There was no difference. Regardless of the orientation of their device, regardless of the time of day or the season, light consistently traveled at the same speed. It was as if the Earth was perfectly motionless within the ether, a notion that was completely impossible. We know the Earth is in motion. So they repeated the experiment. The result was the same. Others replicated it. They too found the same result. For 2 decades, the world of physics was utterly confounded. Some proposed that perhaps the Earth dragged a layer of ether along with it. Others suggested that maybe the experimental apparatus itself contracted as it moved through the ether in just the precise way needed to mask the effect. It was a complete muddle. And then, in the year 1905, a clerk working in a Swiss patent office, a fellow named Einstein, who was pondering these very issues while he was meant to be assessing patent submissions, had a thought. He said, "Hold on. What if everyone has been approaching this from the wrong angle? What if the speed of light genuinely is identical for all observers, irrespective of their motion? What if that isn't a puzzle to be solved, but a fundamental truth about the universe that we must simply embrace? Now, you might protest, that's preposterous. If I am moving towards a beam of light, shouldn't it appear to be approaching me more quickly?" And the answer Einstein provided is utterly mind-bending. He said, "You are correct. Something must yield, but it is not the speed of light. It is time itself, and it is space. They are not fixed quantities. They are not identical for everyone. They are altered depending on your velocity. Consider it this way. Imagine I have a clock. A very basic clock composed of light. It's simply a photon bouncing vertically between two mirrors. Each bounce constitutes one tick. Now, if I am holding this clock while standing still, I observe the light moving in a straight line, up and down, and I can measure a certain duration for each tick. But if you were to observe me and my clock as I flew past, you would see the light beam tracing a diagonal path. This is because while the light is traveling upward, the entire clock is also moving horizontally. For you, the light must cover a greater distance than it does for me. But here is the critical point. We both measure the light traveling at the exact same speed. Therefore, if the light covers a longer distance from your perspective while moving at the same speed, it must take a longer amount of time for you. My clock appears to be ticking more slowly when I am in motion. This is not a deception. It is not a trick of perception. Time genuinely does slow down for a moving object. We have confirmed this experimentally. We have placed atomic clocks on aircraft, flown them around the world, and then compared them to identical clocks that remained stationary on the ground. The clocks that were in flight ran measurably slower, not by a large amount, as the airplanes were not traveling anywhere near the speed of light, but the difference was detectable. We have observed particles that typically decay in a millionth of a second, lasting far longer when they are accelerated to near the speed of light. This phenomenon is real. Now, this is where things become truly fascinating. Let me pose a question to you. Why is it impossible to accelerate an object to the speed of light? Well, let's consider what acceleration entails. It means you are applying a force, and that force is altering the object's momentum. You remember momentum, don't you? It's mass multiplied by velocity. In the old Newtonian framework, if you continuously apply a force to something, you continuously increase its velocity, and in principle, you can make it go as fast as you desire. But that is not how it works. You see, there is a formula that Einstein derived, and it emerges directly from the acceptance that the speed of light is a constant for everyone. This formula indicates that an object's mass is dependent on its velocity. Not the amount of matter it contains that remains the same, but its inertia, its resistance to being accelerated. As you move faster, your inertia increases. And here's the crucial part. As your speed approaches that of light, your inertia approaches infinity. Think about what that signifies. You begin to push a particle, accelerating it. Initially, it is easy, but as it gains speed, it becomes progressively harder to push. You are applying the same amount of force, but you are achieving less and less of an increase in velocity. As you get closer and closer to the speed of light, it requires an ever-increasing amount of energy to gain even a minuscule amount of additional speed. And to actually arrive at the speed of light would demand an infinite amount of energy. You could push indefinitely and never quite make it. We observe this in our particle accelerators. We have these immense machines, miles in circumference, that consume incredible amounts of power, and we can propel electrons to 99.999 mashant of the speed of light, but we cannot get them to 100%. We can add more nines after the decimal, but we can never eliminate that final fraction. It's not a matter of our accelerators being insufficiently powerful. It's that it is a physical impossibility. The universe forbids it. Now, why does mass increase with velocity? This is where the true elegance of the theory reveals itself. Recall that energy equals mass times the speed of light squared, that iconic equation. What that is telling you is that mass and energy are one and the same. They are two different metrics for the same fundamental quantity. When you accelerate an object, you are investing energy into it. And where does that energy go? It manifests as mass. The faster an object moves, the more kinetic energy it possesses, and that energy presents itself as increased mass, which in turn makes it more difficult to accelerate further. You might then ask, well, how does light itself manage to travel at the speed of light if nothing can reach that velocity? And the answer is quite wonderful. Light does not accelerate to the speed of light. It begins its existence at the speed of light always. From the instant of its creation, it is traveling at light speed. How is this possible? Because photons have no mass. Zero. They have no rest mass whatsoever. And an object with no mass, according to the equations of relativity, must travel at precisely the speed of light. It is incapable of going slower, and it is incapable of going faster. That is the only speed it can possess. Here's another way to conceptualize this. The speed of light is not really about light. It is about the very structure of space-time itself. It is the velocity at which cause and effect can propagate. It is the cosmic speed limit for information, Light simply happens to travel at this speed because it is massless, but the speed itself is more fundamental than light. Even if the universe were devoid of light, that speed would still exist, embedded in the very fabric of reality. And this has some truly bizarre consequences. One of them is that nothing can occur instantaneously over a distance. If I wish to transmit a signal to you, the absolute fastest I can do so is at the speed of light. This means if you are 1 light year away, it will take 1 year for my signal to arrive. There is no way to circumvent this. This is the universe informing us that space and time are inextricably linked. You cannot have one without the other. This also means that simultaneity is not absolute. Two events that occur at the same moment for me might not occur at the same moment for you if you are in motion relative to me. This sounds unbelievable, but it is true. Time is not universal. There is no single cosmic clock that everyone can agree upon. Each observer possesses their own personal time, and they are all equally legitimate. I want to share something else with you, something that truly illustrates the depth of this concept. It relates to electricity and magnetism. Now, you might consider these to be two distinct forces, correct? But they are not. They are the same force, merely viewed from different frames of reference. If you have a wire with electric charges moving through it, that constitutes an electric current, and that current generates a magnetic field around the wire. But here's the interesting part. If you are moving alongside the charges, you do not perceive them as moving. Therefore, there is no current. So, there should be no magnetic field, right? But there is one. How can this be? The answer is relativity. When you are in motion, lengths contract. The distances between the charges change, and this change in spacing appears to you as a magnetic field. What is an electric field in one frame of reference becomes a magnetic field in another. They are two facets of the same entity, the electromagnetic field. In Maxwell's equations, the very same equations that predicted the speed of light inherently contain all of relativity. Einstein did not have to alter Maxwell's equations. He had to alter Newton's. Maxwell had been correct from the very beginning. Now, I want to clarify something that often causes confusion. People will say, wait, I have heard of things that can travel faster than light. What about quantum entanglement? What about the expansion of the universe? What about those particles that supposedly went faster than light, the ones detected a few years ago? Remember that? Let me be unequivocal. The speed limit is not about how fast you can measure something's movement. It is about how fast information can be transmitted. It is about causality. Quantum entanglement is real, and it is undeniably strange, but it does not permit you to send information faster than light. When you measure one particle in an entangled pair, you instantaneously gain knowledge about the other, even if it is light years away. But you cannot determine the outcome of your measurement. Therefore, you cannot send a message. The person on the other end has no way of knowing you have made a measurement until you inform them through conventional means, which are themselves bound by the speed of light. As for the expansion of space, that is a different matter. Space itself can expand, and galaxies can recede from one another at speeds greater than that of light due to this expansion. But this is not the same as moving through space. There is no conflict with relativity. And those particles that appeared to exceed the speed of light, that was traced to a faulty cable in the detection equipment. Once it was repaired, the particles were found to be traveling at precisely the speed they should have been, slightly less than that of light. This is why we perform experiments multiple times, why we meticulously check our instruments. The profound beauty of all of this is how it all interconnects. Once you accept the premise that the speed of light is constant for all observers, everything else logically follows. Time dilation follows. Length contraction follows. The increase of mass with velocity follows. The equivalence of mass and energy follows. The unification of electricity and magnetism follows. It is a complete, self-consistent package. You cannot pick and choose which part you like. Nature is revealing something deep about the way reality is constructed, and here is what truly moves me. This entire intellectual edifice, this whole framework of relativity, began because a group of people paid close attention to an experiment that produced the wrong result. The Michelson-Morley experiment was intended to detect the ether. It failed to do so. Most people would have concluded that the experiment was a failure. But Einstein said, no, the experiment was a success. It informed us of a truth about nature. We simply did not like what it had to say. That is the scientific method in action. When your theory is contradicted by experimental evidence, It is not the experiment that is flawed. You must revise your theory. And sometimes revising your theory requires you to alter your most fundamental assumptions about how the world operates. It means conceding that concepts you once considered self-evident, such as the idea that time flows at the same rate for everyone, are in fact incorrect. The speed limit of light is not a restriction imposed upon us by some cosmic enforcer. It is not that we lack the intelligence or the technology to surpass it. It is a fundamental characteristic of the universe in which we reside. Space and time are not distinct, absolute entities. They are woven together into space-time. And the very structure of space-time has this speed integrated into it. To alter that speed limit, you would have to change the nature of space-time itself. You would have to inhabit a different universe. And you know what? I find that to be wonderful. It means that the universe operates according to rules, deep rules, rules that remain constant no matter where you are or how fast you are moving. These rules can be understood. They can be expressed in the language of mathematics. And once you comprehend them, you can make predictions about things you have never witnessed. That is the power of physics. That is the power of a true understanding of nature. So, when someone asks me why we cannot travel faster than light, I explain to them that traveling faster than light would mean violating causality. It would mean that effects could precede their causes. It would open the door to time travel into the past with all the logical paradoxes that would create. The universe does not permit this. And the mechanism by which it prevents this is by establishing the speed of light as the ultimate velocity. Everything in physics is interconnected. You cannot alter one component without affecting all the others. The limit is not really about speed. It is about the structure of cause and effect in our cosmos. It is about the relationship between space and time. It is about the fact that information, influence, and causation must all propagate. They must all travel, and there is a maximum velocity at which they can do so. Light happens to travel at that velocity because light is massless. But the velocity itself is more fundamental than light, and here is the most astonishing part of all. A 16-year-old boy, Albert Einstein, pondered what it would be like to ride alongside a beam of light. It was just a thought experiment, an act of imagination, and from that simple question, pursued with honesty and a profound respect for what experimental data was telling us, emerged this entirely new comprehension of space and time. No sophisticated laboratory was required for the core insight, just clear thought and the courage to follow a logical path wherever it might lead, even if it led to strange and unintuitive conclusions. That is what I cherish about physics. The universe is under no obligation to be easily understood by us. It is what it is. But we have the capacity to figure it out. We can understand it. And when we do, when we truly perceive how it functions, it is more beautiful and more surprising than anything we could have possibly conceived. The speed limit is not a flaw in the universe. It is a feature. It is part of what makes the universe the way it is, consistent, comprehensible, and magnificent. So the next time you hear someone lament, "We will never visit the stars because the speed of light is too slow," remind them that the speed of light is not too slow. The universe is just really, really big. That is an entirely different problem. The speed limit is perfect. It is exactly as it should be. It is communicating something profound about the nature of reality. And if we listen with care, if we truly heed what nature is telling us, we might just learn something that transforms our understanding even more deeply than Einstein did. Because that is the thing about physics, we are not finished. There is still more to comprehend. Relativity and quantum mechanics do not yet fit together seamlessly. We know that both are correct within their respective domains, but we lack a complete theory that encompasses them both. Perhaps when we solve that puzzle, we will gain an even deeper insight into why the universe is the way it is. Perhaps there are deeper reasons, more fundamental principles that we have yet to uncover. But whatever we discover, I can assure you of this, it will be consistent with the constancy of the speed of light. It will respect causality. It will incorporate everything we already know as a special case. That is the way physics progresses. We do not discard what is true. We build upon it. We find deeper explanations, but the experimental results do not change. The speed of light will still be the speed of light. Time will still slow down at high velocities. Mass and energy will still be equivalent. These are truths as certain as the fact that apples fall downward and the earth orbits the sun. And that, to me, is the most wonderful thing of all. We inhabit a universe that is comprehensible. It adheres to rules, deep, elegant rules. And we, situated here on this small planet, with our modest brains that evolved to throw stones and gather fruit, we are capable of discerning these rules. We can understand why there is a speed limit. We can predict what will occur at velocities we will never personally experience. We can observe the universe and comprehend how it operates. That is not a limitation, that is a triumph. The speed limit is not something that confines us. It is something that reveals the deep architecture of reality. And every time we discover something of that nature, every time we uncover a fundamental principle of the universe, we are engaged in a magnificent act. We are understanding the cosmos, and there is nothing, absolutely nothing in the world more exhilarating than that.